So, good morning to everybody. Dear parents and students, what we are really interested is, yesterday we got told you about the three innovative method by which, physics can be learned technically and can be mastered in a easy way. Saying is very easy and doing is a very, very important things. In order to demonstrate the particular things, we are going to take a particular lesson and we are going to do it. We are going to do all the 24 lessons in this systematical way. Before that, we want you to ascertain about three important things: content knowledge, pedagogical skill, technical knowledge. Actually, these are all the three important inputs through which we are going to progress in this particular chapter. Let us get into the chapter. So, dear children, we are going to enter into the physics world called physical world. This is considered to be the NCERT first lesson, though this lesson is really deleted for the coming academic board examination level, but we are really interested to learn the particular content so that NCERT content is thoroughly revised so that you can able to learn the learning continuum in the particular book and why the book is called the best book in the country. So we are going to apply the innovative approach for learning physics. The innovative approach, what we are really prescribing for you is called a TPAC. Content knowledge, pedagogical knowledge, technological knowledge, all the three integrated will form the TPAC, and how we are really going to transact physics so that we can make physics very, very easy for you to understand. Point number one. TPAC is nothing but technology, pedagogy, content knowledge. So, content knowledge, what you are really learning in the particular content. What are all the learning outcomes prescribed in the particular content to make you understand the particular learning outcome thoroughly? What kind of pedagogy I'm supposed to apply? What kind of technical knowledge I'm supposed to imply so that the content knowledge is gone into your mind thoroughly is nothing but the TPAC strategy. For example, in the particular chapter called physics, we need animation to explain some important concept. So, content knowledge is one area. Pedagogical skill of the teacher is another very, very important area. Technological knowledge through which the difficult part can be easily be getting to you so that all the three combined is called TPAC. We are going to do the things in physics for yourself. Another very, very important thing. Whenever a lesson is taught, you remember the learning content. After remembering, you try to understand the content. After remembering and understanding, you try to apply the content in the concept. After remembering, understanding, and applying, you want to analyze what is the use and pros and cons of the particular concept. Based upon your analyzation, you can evaluate and you can create your own things. This is the Bloom's taxonomy by which the textbook is really being designed. We are going to apply a new technology called Solo taxonomy, in which first we will give the information. We will give related information. Based upon the related information, you are supposed to connect the information and connect the information to the previously learned content so that it may reach your permanent memory. I can simply say, when a lesson is there in a particular standard, already I have told you, physics is based on 4 important themes: moving things, how things work, natural phenomena, natural resources. The theme is divided into sub-themes. Sub-themes were classified to standards. Each standard there may be a lesson in physics that may be expecting some learning outcomes. Each learning outcome is learned thoroughly and it is related to the theme, and then it is related to the previous classes, and also it can extend its knowledge to the next classes. The solar taxonomy can do the wonder in yourself. We are going to approach in a systematical way. So, dear friends, outcome-based education is a modern technology that is being employed in all the developed countries. What is outcome-based education in physics? Already I told you, there are 4 important themes by which the physics was really being developed. Moving things, how things work, natural phenomena, natural resources. A theme is divided into sub-themes. Each sub-theme is allotted to a class by means of a curriculum. The textbook develops the sub-theme into a lesson. Lesson prescribes some learning outcomes. Outcome strategy is a very, very important strategy in which we are really interested in focusing on the learning outcome, which is nothing but the compilation of the learning outcome gives the ultimate output of the lesson, so that our sub-theme objective is really being achieved. So, in order to learn the theme, we have to master the sub-theme. In order to master the sub-theme, we have to learn the lesson. Rather than learning the lesson, if we master the learning outcome, automatically sub-theme will be mastered, theme will be specialized. So, outcome-based education strategy we are going to adopt. Let us see how we are really going to do it. Today, for this important video lesson, we are going to concentrate on 5 learning outcomes prescribed in the physical world. What is science? What is scientific method? What is the difference between philosophy and science? What is physics? What are all the major outreach of physics? What are all the branches of physics? These are all the 6 important learning outcomes in the first part of the physical world. Now let us learn the content in a systematic way. Point number 1. Over the 20 centuries, there is a great understanding between the nature and the mankind. Mankind is always exploring the nature because man is always amused by the nature, puzzled by the nature, surprised by the nature. Mankind, in order to survive, in order to conquer, explore nature and can be able to find some important things. The wonders of nature, day and night, season cycle, eclipses, tides and tsunamis, volcanoes, rainbows, northern lights. Some are called miracles. Some are called amusement. Some are called threats. Some are called wonders. Nature exhibits lot of things. In order to survive, in order to conquer, man has got the interest in exploring the nature. Because of the inquiry nature of the mankind, the puzzles, amusements, and a lot of things that are exhibited by nature, mankind want to explore for the survival, for to save, for to conquer. Mankind explores nature. Over the 20th century, mankind closely observed the nature and found a lot of things. It saved the findings for the future generation to survive and to conquer. So, the ultimate learning outcome expected from the lesson is nature exhibit miracle. If mankind can able to find the answer for the miracle, then it may be converted into science. science become technology. When the science will become technology, the findings from science, if it is put into use for the mankind, will become technology. Miracle, answer for miracle is science. Science put into use means technology. If technology is useful, we'll go for the industry. So we are learning science here in order to help the mankind, in order to save the mankind, in order to survive in the nature. So miracle answer is science. Science use is technology. Technology put into use is called production. The ultimate lesson output is we have to convert nature's miracle into technology and industry. Actually, let me give you an example. In olden days, random fires would be there seen in the forest. Men really thought that, it is nothing but a ghost. After careful observation and research, mankind found that it is nothing but the rotten objects can produce a gas. It is always ignitable. Now, the science helped the technology in which, the gas was put into a cylinder and it can be used as a cooking gas in the kitchen. So, mankind converted the science into technology, and the mankind is its job, and production is really being made, and every house is now having the gas cylinder in it. So nature exhibits something, man closely observe, find the reason for that, and then call it as a science. Science can able to ease the mankind burden so that technology comes out. When technology was put into use, production is really being coming. So industries are really being developed. So the ultimate objective of the lesson is why there is science. Let us understand this. So, first learning outcome. In order to overcome the nature's threat, in order to understand the nature's amusement, in order to understand the bustle activities of the nature, mankind want to survive in the nature, mankind want to explore the nature, mankind want to conquer the nature. To find these results, in order to find the answer for the nature. The nature is exhibiting a lot of things. Mankind want to find the answer. Science is nothing but the answer for nature's calling. So, man uses the scientific method. Scientific method is nothing but close observation, findings, questioning the findings, forming an hypothesis, testing the hypothesis, finding the results, and stipulating the findings as the laws. And this is nothing but science. So, systematic observations, controlled experimentation, qualitative and quantitative data, arriving the logical reasoning, developing a mathematical modeling, prediction, verification, falsification of theories. Scientific method is the methodology by which mankind observe the nature and deduce a result, and the results are given in the form of laws and principles. Nature exploration by scientific method will result into laws and principles. Laws and okay. In order to survive, in order to conquer, nature threat, nature amusements, nature puzzles, nature beauties were studied through scientific method, and the knowledge about the nature, the pattern about the nature's pattern are tabulated in the form of laws and principle, which is nothing but science. Very simple learning outcome. Nature exhibit lot of fun, lot of beauty, lot of joy, lot of threat, lot of other things. In order to survive, in order to conquer, in order to inquire, mankind uses scientific method and knows about the pattern and knowledge about the nature. Pattern and knowledge are converted into proved scientific facts such as laws and principles, which is nothing but science. Okay. Scientific method is one in which you know lot of observations, lot of experimentation, lot of data were collected. The data were arranged logically and the reasons were compiled in the form of a knowledge, and the knowledge will be distributed to the mankind, such as laws and principles were comprised of science. Systematic organization of knowledge got through the scientific method gives the truth about the nature. Knowing the truth about the nature is nothing but the science. Science is derived from the Latin word scientia. That is the first learning outcome. Then, over the civilization, up to 16th century, man knows about nature, man finds something from the nature, man inquired about the nature. All these findings were classified as philosophy, and it was told and it was followed scrupulously by the mankind. So philosophy is one which is the outcome that the man derived from the nature, and it was told as the facts. There is a difference between philosophy and science. In 19th century, science emerged. Science proved the hearsay facts, in the experiment by experiments, and called it as a laws and principle. Philosophy is converted into laws and principle. We call it as a science. Philosophy is nothing but traditions, cultures, hearsay that mankind derive from nature. Science is proved facts. Second learning outcome. So ancient civilization, by means of close observation, by means of inquiry, knows lot of facts. These facts were told as a philosophy. Up to 16th or 17th century, the civilization facts were classified as philosophy. After that, in 19th century, a word called science was derived based on the scientific method, in which, though from the Indus Valley civilization, though the mankind knows lot about mathematics, science, astrophysics, medicine, lot of things were known to the mankind. But these things were scientifically proved and then called as a science in 19th and 20th century. So the difference between the philosophy and science is, up to 16th century, what man knows about nature is called a philosophy. After 19th century, proved fact, verifiable facts will become science. So, up to 16th century, civilization learned about nature, hearsay, tradition, cultural facts about nature were really termed as philosophy. After 19th century, every fact, hearsay or known about the nature was proved in the experiment. Verifiable, proved facts were told in a simple, understandable language called laws and principles. The laws and principles are proved verifiable facts, which is called science. Known facts is called philosophy. It is the learning outcome. There are three worlds. Macro world, which is nothing but astrophysics. Meso world, that is nothing but the real world. Micro world, that is nothing but atom and nuclear world. These are all the three worlds in which the universe is spread about. In order to understand the three worlds, in order to explore the three worlds, science is making a systematical attempt through a scientific method. So, the theory and observation and experimentation are the progress of science in which facts verified, experimented, and was told as laws and principles. The laws and principles are not static. Philosophy is static. Once told is never changing. Tradition is not going to change. Culture is not going to change. But science is ever dynamic. There is no final theory in science. No unquestioned authority among the scientists. Science allows changes. For example, regarding the theory about solar system, originally it was thought as Earth as a center. Later it was found it was false. Then they really predicted that sun is the center. Of course it is right. Then they say all the planets are rotating around the sun in a circular orbit. False. They found that it is elliptical orbit. So the facts are really changing. After every verification, science takes a new shape. Likewise, there is another example. Regarding the nature of light, Newton says that it is a corpuscular thing. Light is a particle. Huygens says light is a mechanical wave. Maxwell said that light is an electromagnetic wave. De Broglie said it is a matter wave. For example, light is a particle, light is a wave, light is a wave particle. So many thoughts about one particular thing, that is the diversity of science. So, we learned about three important things. What is science? Mankind explored nature and found some facts about the nature. The knowledge, principles, laws derived from nature is called science. The systematic knowledge about science, nature is called science. Originally, up to 16th century, the knowledge about nature is called as a philosophy. In 19th century, science is a term that is being used. Science is nothing but the proved facts. So proved fact is science. Hearsay fact is called philosophy. Next very important things in the learning outcome is physics. Actually, science is the branch which can be classified into two important areas. One is called physical science, which is going to study about the non-living things. Another one is called biological science, which is going to study about the living things. So physics is a discipline which is in the category of natural science, which includes chemistry, where physics is meaning is nature. In Sanskrit, the equivalent is physical world. Physics really studies the properties of matter and the energy. The relationship between the matter and the energy is really being studied in a systematical way in physics. Mutual relationship between the matter and the energy is the ultimate one, which is called physics. So, Einstein is one who really correlates the matter into energy. E is equal to mc square. So, the thrust areas of physics can be classified into two ones: unification and reductionism. For example, Newton has really found a law called Newton's gravitational law. By just laying down on the floor under the apple tree, he found that the apple which is falling down is obeying the law called Newton's gravitational law. The law, which is very simple, found in the meso world, in the living world, can be applied to all the three worlds. So we call this unification approach. A simple law can be applied to all different conditions. A simple law can be applied to everywhere. It's called unification. Second thing is reductionism. There are large number of properties that are found about the matter. There are large amount of properties that are found about the energy. All the things are simply related by one simple equation called E is equal to mc square. The particular relation says, how the matter can be converted into energy. That is called reductionism. So many findings to one single law. So, unification is the act of unifying the different laws valid for different phenomena into a single theory that explains all the different phenomena. Newton's gravitational law explained the planetary motion. Newton's gravitational law explains about the particle nature. Newton's gravitational law can able to explain about the atomic movements. So a single law can be used in all the three different platforms, which is nothing but unification, or otherwise we call it as a universal law. Breaking down a complex system into simple constituent system, so that the laws of physics can be applied on the system and we can understand the working of the complex system. For example, thermodynamics is the branch of physics. There are so many things are derived in thermodynamics. Kinetic theory of gases is a postulate that can be able to explain all the thermodynamical concepts. A single principle can be able to explain all the thermodynamic properties. So, kinetic theory of gases uses the reductionism principle. So, Newton law is an ultimate example for unification. Unification is a very, very important concept. Diverse physical phenomena can be explained by a simple concept. So, the law is applicable to all the three worlds: meso, macro, micro. So, it is called a universal law. Similarly, Maxwell's law. The Maxwell's electromagnetism law can able to explain all the phenomena above, like this is another very, very good example for unification. So, reductionism, we already told, so many complex systems can be break into different parts and can be explained by a simple things. So, thermodynamics is a very, very important example in which, all the concept about thermodynamics can be explained by kinetic theory of gases. So, now we are passing on to the very, very important things. Science is classified into physical science and biological science. Physical science uses two important thrust areas. One is called unification, another one is called reductionism. By means of this, it can be able to explain all the physical properties of nature. So, generally, we got told about the three worlds: macro world, meso world, micro world. The study of the macro world and meso world is called classical physics. The study of the micro world is called modern physics. So, classical physics has got different branches. Modern physics has got different branches. We are really going to learn about the different branches of physics in this particular part. So, dear friends, we have learned about the learning outcomes in a systematical way. What is science? Mankind, over the 20 centuries, carefully observe the nature and find the facts about the nature and told this as, and compiled it as a law and principle. The laws and principle and the knowledge of systematic knowledge about nature is called science. Very good. What is the difference between philosophy and science? In 16th century, hearsay facts about the nature is called philosophy. Proved facts is called science. What is scientific method? Scientific method convert the controlled experiments, careful observation, controlled experiment, data into logical reasoning. After the logical reasoning, predict, form the hypothesis, laws, principles. Scientific method deduce the observations into laws and principles. So, three important facts. Fourth one, what is physics? Physics is nothing but matter and energy. It studies the matter and energy, the interrelationship between the matter and energy. It studies the particle nature in physics. Physics is a branch which studies the nature, which relates the matter and energy. Next, very, very important things. What are the thrust areas? The major thrust area in physics is two. One is called actually reductionism. Another one is called, you already know this, unification. Unification, reductionism. What are all the examples? What are all the branches of physics? These are all the outcome we have learned so far in physics in the particular things. Rather than learning the lesson thoroughly, learn the concept thoroughly, learning outcome thoroughly, and then you are really mastering the content in a more systematical way. Physics learning is a scientific way. We are really following the scientific way so that physics can be easily understood by each and everyone. Thank you.